So crystals with high coordination number shows this type of defects. Okay. So high coordination number generally is 6 to 8. And stoichiometric defect, which is Schottky defect, it arises due to missing of cation from, it is due to missing of cation from its lattice point to maintain electric neutrality. Same number of anions also missed from the lattice points. So, ratio between cations and anions remains same. Okay. Then, due to the missing of anions and cations from the lattice point outside the crystal, density gradually decreases. Okay. So, due to the missing of these ions, cation and anions, vacancies are created. These vacancies are nothing but empty spaces, holes. Okay. So, when ions, they are escaped out, density gradually decreases. So, due to this, density decreases. Density decreases. So, with the creation of holes here, conductivity increases. Density decreases, conductivity increases. Conductivity increases. Okay. Then coming to some examples regarding Schottky defect. NaCl, KCl, cesium chloride, and also silver bromide, etc. So all these are comes under Schottky defect. Okay. Then next point defect, that is stoichiometric defect, Frenkel defect. Frenkel defect. Okay. So Frenkel defect, this is also vacancy defect. Point defect, vacancy defect. And it also arises due to the missing of cation from its lattice point. But in this type of defect, missed cation remains in the crystal itself. Missed cation occupies the interstitial position present in the crystal. Okay. So this is also vacancy defect due to the missing of cation from its lattice point. But missed cation occupies interstitial position within the crystal. Okay. So due to this, density does not change. Okay. Then Frenkel defect, that generally takes place with the crystals having least coordination number. Okay. Low coordination number. So it takes place in crystals having low coordination number. Okay. Then coming to Frankel defect. So it is due to the missing of cation from its lattice point. So this is a crystal lattice. If a Frankel defect takes place in this crystal, so Frankel defect is due to missing of cation from its lattice point. So this is the cation position. So cation present here, it escapes and occupies the interstitial position. So this position is called interstitial position. Okay. So missed cation from its lattice point that occupies this position, interstitial position. So ion remains within the crystal itself. So that's why there is no change in the density. Whereas in Schottky defect, ions escapes out from the crystal. That's why density gradually decreases. But in case of Frankel defect, ion remains within the crystal. That's why no change in the density. Okay. Then this type of defect, Frankel defect, it generally takes place with the crystals having low coordination number. For example, it takes place in zinc sulfide, silver chloride, silver bromide, silver iodide, etc. Okay, silver halides. Okay, so one thing here is silver bromide AgBr shows both Schottky and Frankel defects. Okay, so it shows both Schottky defect and Frankel defect. And here in Frankel defect also conductivity increases. Why? Because due to the missing of cation, a hole is created here. So this is cation vacancy. Cation vacancy or cation hole. So due to the presence of hole here, conductivity of crystal that gets increases. But there is no change in the density. Why? Because here missed cation that occupies the interstitial position. That's why Frankel defect is also called as interstitial defect. Okay. So Frankel defect is also called as interstitial defect. Okay. So this is about stoichiometric defects. Schottky defect and Frankel defect. So two types of defects. Then coming to non-stoichiometric defects. Non-stoichiometric defects. So non-stoichiometric defects, again different types are there. So coming to metal excess defect and metal deficiency defect. So non-stoichiometric defect, that is generally in two types: metal excess defect and metal deficiency defect. Metal excess defect again in two types: metal excess defect due to anion vacancy and metal excess defect due to cation vacancy. Okay. Then one more thing is metal deficiency defect. First coming to metal excess defect due to anion vacancy. Okay. So, in metal X is defect due to anion vacancy.